Using second derivatives. The second derivative can be used to determine whether a curve is concave or convex for a given domain. When a curve changes in this way, it's sometimes referred to as a change in concavity, although that term may not be one regularly used in your class. So what do we mean by this? If the curve is this shape, then it's concave. And this occurs when the second derivative is negative. You might know the second derivative test for a maximum. So when the second derivative is negative, it's telling us that the curve is concave. And so if there's a turning point in there, it will be a maximum turning point. If it's this shape, then it's convex. And here the second derivative will be positive. And the same thing applies when we talk about the second derivative test for a turning point and find a minimum. You may find textbooks in which concave is referred to as concave down, and convex is referred to as concave up. I quite like this definition, and the reason is concave up is U-shaped, and therefore it's easy to remember. But what you need to remember is that when it's up, it's convex. Consider the part of a curve between two turning points, such as this. We know that the first derivative is 0 here at the maximum, and also here at the minimum. So the gradient is 0 in both of these places. So going from 0, you can see it's a negative gradient along here, and it's going to get steeper for a while, and then it must get shallower as it goes back in towards the gradient being 0 again. So there would be a steepest point somewhere in between. At this steepest point, the second derivative is 0. This point is known as an oblique point of inflection. An oblique point of inflection is a point at which the concavity changes, because we can see that it's concave up here and convex down here. And it changes the concavity at this point here, going from N shape to U shape. So up here on the curve, the second derivative is negative, and down here, the second derivative is positive. Now, I mentioned this before, but it's worth reiterating. This is why the second derivative test for turning points works. Minima occur on portions of the curves which are concave. Minima occur on portions of curves which are convex. And maxima on portions of curves which are concave.